Hello everybody, and welcome to another recording, this time paper 2, Tuesday 13th of June 2023 it was set, Edexcel's A Level Maths. So it's the pure paper, second one. Let's get straight to it and have a look at the questions. So let's start, of course, unsurprisingly, with question number 1. So we have a function f of x defined as x cubed plus 2x squared minus 8x plus 5. We need to find f double dashed of x. Some teachers might call this f prime prime. All this means it's just notation. This means we're going to take the function x, we're going to differentiate it not once but twice because of these two primes. So first of all, if we differentiate f of x to get f prime of x, we'll get this expression here. X cubed becomes 3x squared. The power comes to the front, then we reduce the power by 1. 2x squared becomes 4x because of the same reason, and minus 8x goes to minus 8. So then we have to differentiate again to find the second derivative. So finally, the second derivative becomes 6x plus 4. 3x squared becomes 6x, 4x becomes 4, and the constant term minus 8 vanishes, just as that 5 vanished when taking f dashed of x. Part B comes in two parts. B part 1, we need to now solve when the second derivative is equal to 0, which luckily is quite easy because we found what the second derivative is from part A. So solving when this is equal to 0, we just set 6x plus 4 equal to 0. So for B part 1, just set this equal to 0, then solve this very, very simple equation. So of course we're going to take 4 off both sides first. 6x is minus 4. Then dividing through by 6, we can clearly see that f double dash of x, the second derivative is going to be 0 when x is minus 2/3. For part 2 it says, hence find the range of values of x for which f of x is concave. There's convex and concave. A curve is concave if the section of it literally looks like a cave. Here's a drawing to illustrate what I mean. Concavity is the region on a graph of a function when the second derivative is less than 0. It's when the gradient is becoming more and more negative. A very positive, less positive, less positive, a 0 gradient, negative, more negative, more negative. So it will look like a cave. So if we're wanting values of x for which f of x is concave, we're wanting the region for when the second derivative is less than 0. It's equal to 0 exactly when x is minus 2/3. If I want the second derivative to be less than 0, because 6x plus 4 will then get bigger, I therefore need x to be less than minus 2/3. So the conclusion for B part 2, using B part 1, is that f of x is concave for when x is less than negative 2/3. Now, this is defined slightly ambiguously, so don't get too hung up if you put a strictly less than or equal to. Marks are awarded for whether you use strictly less than or the less than or equal to. Question 2, we're talking about sequences now. We've got a sequence u subscript 1, u subscript 2, and so on, defined as follows. So u1 is 35, and then this is a term-to-term rule. So the next term along, un plus 1, is a previous term plus 7 lots of cosine n pi over 2, where n is the previous term's number, minus 5 times minus 1 to the power of n. So our job for A part 1 is just to show that u2 is 40. Using this expression here and subbing in for u2, think of u2 as being u of 1 plus 1. So u2 is going to be the previous term, u1, plus 7 lots of cosine of 1 pi over 2, because n is now 1, we're finding 1 plus 1, which is u2, then minus 5 times minus 1 to the power 1. So u1 we saw was 35, that's been told to us. Cos of 90 degrees is 0, check that on your calculator if you want to, of course, and minus 5 times by minus 1 becomes positive 5, and so the expression becomes this. So we just get 35 plus 5, hence u2 is 40. For A part 2, in much the same way, we now need to find the value of u3 and the value of u4. So for part 2, u3 will be u2 plus 7 cos 2 pi over 2 minus 5 times minus 1 squared. u2 was of course 40. Cos of pi is negative 1, so we get 7 times minus 1 minus 1 squared becomes positive 1, so minus 5 times positive 1 gives us minus 5. So this is going to be 40 minus 7 minus another 5. U3 is therefore 28. U subscript 4, in exactly the same way, will give us this value here, and if you carefully put this in, you should find that U subscript 4 is 33. Now we're told that the sequence is periodic with order 4. So for B part 1, we need to use this information to write down the value of U subscript 5. So what does a periodic sequence mean? If it's periodic, it means it repeats, and the order tells us how many terms are in each repeating block. So periodic with order 4 means that there's 4 terms in each block before the cycle then repeats. So to illustrate, here's a section of the sequence above. Block of 4, U1, U2, U3, U4. Then repeat back to the same U1, U2, U3, U4, and so on. So I've underlined a block of 4, and this blue block of 4 will repeat indefinitely. So because of this, we can see that U subscript 5 is going to be the first one after a repeating block. So U subscript 5, as you can see here, literally 1, 2, 3, 4, 5, it's got to be 35. B part 2, find the value of the sum of the first 25 terms. If you really, really wanted to, if you weren't sure what I'm going to tell you now, if what I'm going to say now doesn't make any sense, you could honestly just do 35 plus 40 plus 28 plus 33 and manually do this 25 times, add them all up. It's a painful way of doing it, but if it gets you a mark, it gets you a mark. The better way of doing it is what I'm going to suggest now. We use this idea of how many terms are in each repeating block. It's periodic of period 4. So the first 25 terms, how many blocks of 4 fit into 25? Well, I could fit 6 lots of 4. So I could find the first 24 terms, then just add on the 25th one. The first 24 terms is 6 lots of this block of 4. So that's the same as saying want 6 lots of this repeating block plus the 25th term. Well, if I look at U5 now, 1, 2, 3, 4, 5, the 5th term is 35, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So we can see here, because of it being periodic, the 25th term comes right after, obviously, the 24th, in the same way that the 5th came after the 4th. And so in the same way, because the 25th one is the first number that begins a new repeating block, this must be the first term in the repeating block itself. U25 will be 35. You've got 6 lots of this block, so the 24th term would have been 33. U25 would be 5. So what we're actually adding up now is this expression. Repeating block of 4, 6 times, plus U25, which is 35. And if you try this on a calculator, typing it in very carefully, you should find that the sum of those terms comes to 851. Question 3 is about logarithms. So log base 2 of x plus 3 plus log base 2 of x plus 10 equals 2 plus 2 log base 2 of x. We need to show that 3x squared minus 13x minus 30 equals 0. First of all, I'm just going to write down the equation we have here. So not changed anything yet. Just consider the left-hand side for a moment. We've got log base 2 of something plus log base 2 of something else. Remembering our laws of logarithms, if we've got log of a plus log of b, assuming the logs are to the same base, that can be combined into a single log. Log a plus log b becomes log of ab. So I can combine these two brackets into a single logarithm. The left-hand side will become log base 2 of x plus 3 multiplied by x plus 10 equals 2 plus 2 log base 2 of x. So all done here, combine this log and that log into one single log. Log a plus log b equals log a times b. It would help with consistency for this question if all terms were in terms of log base 2. This 2 here is a problem. So what I can do here is sort this 2 out, and as well, think about how to rewrite log base 2 of x. Well, first of all, to write 2 in terms of log base 2, what I could do here is just do 2 to this power. 2 squared is 4. So in terms of log base 2, 2 is the same as log base 2 of 4. And again, using another law of logarithms, if there's a coefficient at the front of a log, that's the same as putting the coefficient on top of this variable to that particular power. So 2 log base 2 of x is the same as log base 2 of x squared. Normally, this step goes in reverse. Normally, we start from log base of 2x squared, then I'd say to put the 2 to the front. But anyway, sorry, almost lost my voice there. So anyway, what I was saying here, by writing it in terms of log base 2, it just makes it easier to manipulate, because everything now is all in terms of log base 2. The next step again, because now I've got log base 2 of something plus log base 2 of something else, like the very first step, I can combine this side into a single logarithm as well. So log base 2 of 4 plus log base 2 of x squared becomes log base 2 of 4 times x squared. In other words, just 4x squared. Now look what we have. We've got log base 2 of something equals log base 2 of something else. The left-hand side equals the right-hand side. The logs have equal bases, therefore what we're taking the log of must also be equal. So the key thing here is to deduce if log of A equals log of B, then A must equal B. So we can actually sort of forget the logs now and just deduce from this step that x plus 3 multiplied by x plus 10 must equal 4x squared. I'm going to write 4x squared first though. I'm going to write it as 4x squared equals x plus 3 multiplied by x plus 10. So now at least we have a quadratic, so we're on the right lines. If we expand out these brackets, we'll get x squared plus 13x plus 30. Then the final step is fairly trivial. We need to get the right-hand side equal to 0. So if I minus off the x squared, minus off 13x, and minus off 30, you can hopefully see it's going to be this quite clearly. So therefore, we don't need to show to the examiner the next step because it's implied, it's obvious what's happening. Taking 1x squared away from 4x squared yields 3x squared. Minusing 13x gives this. Minusing 30 from both sides obviously gives a minus 30 equals 0. So we've shown it as required. B comes in 2 parts. So B part 1, we need to write down the roots of the equation 3x squared minus 13x minus 30 equals 0. So again, if I just write this down first of all, this one is, to be fair, a very nice question. This is essentially GCSE. We could use our calculator and just solve this using the quadratic solver on the calculator if you wanted. This would actually factorize as well. So whichever way around you want to do it, I'm going to assume you'd use a quadratic formula, which I'll show you now on this version of the ClassWiz. So what we can do is menu, go to option A, which is equation slash function. We want to solve a polynomial, degree 2 because it's quadratic. Now if I type in here, 3 is my x squared term, minus 13 is my x term, the constant term minus 30, press equals again to get the solutions. My first value is 6, my second value is minus 5 over 3. So therefore, x will equal 6 or x will equal minus 5 over 3. You need to be slightly careful here. The force of habit might just tell you to just underline the x equals 6, reject that because you can't take a negative, you can't do log of a negative value, so underline that and move on. But actually this question twists it slightly. Here you need to say which one is not the answer. So which one of these is not the solution. So as long as you remember that taking a log of a negative value is undefined and just don't do the automatic, oh, it must be x equals 6 and moving on, then you're absolutely going to be okay here. So essentially, which one is a non-solution? It's going to be x equals minus 5/3. Because if I tried on this term here doing log base 2 of minus 5/3, in fact, you try it yourselves if you don't believe me, you'll get a math error on your calculator. It's undefined. So that is the reason for the answer. So first thing to say, this is the not solution. Second thing, the reason. So concluding, x is not going to be equal to minus 5 over 3. And the reason, it's since log base 2 of minus 5 over 3 is undefined. Question 14. Coffee is being poured into a cup. So, what about this coffee? Well, the temperature of the coffee, H, guessing capital H because it's hot, who knows, H degrees Celsius, 2 minutes after being poured into the cup, is modelled by this equation here, given as an exponential. A and B are constants we need to find. We're told that initially the temperature of the coffee was 85 degrees Celsius. Based on that, we need to find the value of constant A. So what does this mean? So it means the word initially essentially is saying when the time is 0. So from the off, when t equals 0, h, the temperature, must be 85. So this is our in, this is our way in. If we make the substitution, we can work out what a is going to be. And so h becomes 85. When we get a e to the 0 plus 30, we're going to get a e to the 0 because when the time is 0, minus b times 0 just becomes 0. That's why it becomes 0 here. Now, any number to the power 0 is 1. So a times e to the 0, well, that's just a. So we get 85 as a plus 30. So what we need to do now is take 30 from both sides. Therefore, a will be 85 take 30. A is 55. Part B, again this word initially. Initially, the coffee was cooling at a rate of 7.5 centimeters, what? 7.5 degrees Celsius per minute. Find a complete equation linking h and t, giving the value of b to 3 decimal places. So initially again means when time is 0. Cooling, keyword here, rate, we need to eventually take dH by dt. We need to differentiate this temperature with relation to time to find the rate of change of the temperature. In other words, the cooling rate. So what we can say here is the following. Using this information, cooling, of course, means temperature is going down. So dH by dt initially is minus 7.5. Just be careful to include that minus. So when the time's 0, the initial rate of change of temperature is minus 7.5. It's cooling down by 7.5 degrees per minute. So what we need to do now is to actually differentiate this with respect to time. So the model, inputting what a actually is, if I sub in that a is 55, h equals 55 e to the minus bt plus 30. So if I differentiate this now, the 30, the constant term will vanish, and this minus b will drop to the front and be multiplying the 55 coefficient. In other words, dH by dt is just minus 55 times b, e to the negative bt, and that plus 30's vanished. However, we're told that that particular rate, when the time is 0, is 7.5, minus 7.5 rather. So the next line, we can sub in dH by dt is minus 7.5, and then we're going to get minus 55b e to the 0 again, because once again, because of this word initially, we sub in time is equal to 0, so minus b times 0 gives 0 again. E to the 0, like I said before, is just going to be 1, so this simplifies to just minus 7.5 is minus 55b. Final step, if we divide by minus 55 to isolate b, b is going to be minus 7.5 divided by minus 55, which as an exact fraction is going to give us 3 over 22, but because we want b to 3 decimal places, we're going to round it off to 0.136. Read the question carefully though. We don't just stop at b, we need to find the complete equation linking h and t. Well, this is the equation. Now we know a and b. If we just input a and b into this, we've done the entire question. We've already substituted in a as 55, so to finish off, if we just substitute in that b is 0.136, our final answer is h equals 55 e to the minus 0.136t plus 30. It is a minus here because the minus is embedded in this question. Minus b, b is positive, so minus a positive, hence minus the positive 0.136. Question 5 is a curve, capital C, with equation y equals f of x. It passes through the point P, which is at 3 minus 10, and has a turning point also at P. We're told that the gradient, dy by dx, the derivative of f of x, is 2x cubed minus 9x squared plus 5x plus some constant k. We need to show that this k is equal to 12. Well, the key thing here is, at P, there's a turning point. A turning point means that at that particular point, the gradient dy by dx must be 0. So we can set dy by dx to be 0 at point P. However, dy by dx, we have an expression for this, and at point P, because dy by dx depends on x, it's a function of x, and we know the value of x at p, we can sub in the value x being equal to 3 to work out the gradient at point P. So therefore, this dy by dx, 2x cubed minus 9x squared plus 5x plus k will be 0 when x is at 3, because that is where we're at point P. And at point P, the gradient is 0 because it's a turning point. So all we need to do now is input x equals 3 into this expression here and set it equal to 0. So 2x cubed minus 9x squared plus 5x plus k becomes this when we input x being equal to 3. 2 times 3 cubed minus 9 times 3 squared plus 5 times 3 plus k equals 0. If you try this on a calculator and simplify slightly, you should arrive at 54 for 2 times 3 cubed, minus 9 times 3 squared is minus 81, 5 times 3 15, plus k. This will neaten again to just simply k minus 12 is equal to 0, so add 12 to both sides. We can see that therefore k equals 12, which is what we needed to show. Part B begins with the word hence, so we're going to use part A to help us. We're going to find the coordinates of a point where the curve C crosses the y-axis. So we don't have an equation for C, we have the derivative of C. So to go from the derivative of a function to the function itself, to go from dy by dx to y, we need to integrate. So therefore, curve C will be the integral of this with respect to x. Because dy by dx, we can now add a bit to this, because we now know k is 12, dy by dx is 2x cubed minus 9x squared plus 5x plus 12. So to find y, in other words to integrate this, we're going to see that y is going to be the integral of all this with respect to x. So performing the integration, 2x cubed becomes 2x to the power 4 divided by 4. That will become a half x to the power 4. Talking through the other terms in a similar way, x squared becomes x cubed divided by 3, and this 9 divided by 3 gives us that 3 here, but it's all minus, so hence minus 3x cubed. 5x becomes 5x squared divided by 2, 12 integrates to 12x, plus of course the infamous constant of integration, which we'll need to find in a moment. So how to find this constant of integration? Well, we do know these conditions. We know that when x is 3, y is minus 10, because we're given that this curve must pass through point P. So we can substitute in these conditions. So when y is negative 10, x is 3. Or we could say x is 3, y is negative 10, vice versa. So if I input this into this expression, minus 10 will equal all of this when x is equal to 3. So minus 10 will be half of 3 to the power 4 minus 3 times 3 cubed plus 5 over 2 times 3 squared plus 12 times 3 plus c. Just switching each instance of x for the value 3 because x is 3. So let your calculator do the legwork here. Type this in and neaten it up. You should find that minus 10 on this side, all of this here is actually just 18. So minus 10 is 18 plus c. If I subtract 18 from both sides, the constant of integration is minus 28. The curve, I do half apologise. I say half apologise because I do like using the constant of integration as capital C, but because the curve is also defined as capital C, I do hope this isn't too confusing. C here means the constant of integration is negative 28. We want the coordinates, not just y-intercept, but the coordinates of where it crosses the y-axis. So essentially, if we input x being equal to 0, because when we cross the y-axis, x is 0, all these terms vanish, and we just get c. So when x is 0, y will be minus 28. Hence the curve cuts the y-axis. When x is 0, we'll just have this constant of integration, which is negative 28. Question 6 is a question about applying vector geometry to a modelling situation. In this particular point, we're looking at running around a track. So one option we could do, we could maybe sketch this out. You don't have to, but you could. So I've got this information for A, B, C and D with all these position vectors. 4 different points. So what I could choose to do is sketch out on an I, J coordinate grid these position vectors. If you're more of a visual learner, and you might see this as a way into picturing what you need to prove. So a rough sketch, I goes along in like the x-axis direction, j goes up and down. You should find the sketch looking something a bit like this. So B is 16j, so 16 up. A is 12i, so just 12 along. D, 22 along, 24 up. And C, 50 along and quite far up, 136 up. We need to show that AD is parallel to BC. Now to do that, we need to remember the key concept for if two vectors are parallel to each other. If one vector is parallel to another, then that vector can be written as a multiple or a factor of the other one. So all we need to do is to show that AD is a multiple of BC or that BC is a multiple of AD, either way round. So let's think about vector A to D. So to go from A to D, I'm suggesting we go from A to O, then when we're at the origin, go from O to D. So A to O will be the opposite of O to A. So that's going to be minus 12i plus the position vector of D, which is 22i plus 24j. If we simplify this, we'll get 10i plus 24j. In exactly the same way, we can do the position vector of B to C. To go from B to C, I'm going to go from B to O, and then from O to C. B to O will be minus 16j, because I'm not going from O to B, I'm going B to O, the opposite way. So minus 16j for this one, plus this expression for the position vector of C, gives us minus 16j plus 50i plus 136j. 50 minus 16, sorry, my bad, 136 minus 16 gives 120 for the new j component, and the I component will be 50. So this simplifies to 50i plus 120j. And if we compare AD to BC, hopefully you can quite clearly see that BC is 5 times bigger than AD. So if I factorise out the 5, like so, then we can explicitly see and make it very clear to the examiner that we know exactly what we're doing. We've factorised out the 5, we've got AD in brackets essentially, but I'm going to say again to be perfectly clear, this is 5 lots of AD. So you need to show as clear as possible that BC is some multiple of AD, or you could show that AD equals 1/5 of BC alternatively, and then conclude that therefore AD is parallel to BC. Now for part B of this question, it comes to the modelling. We're talking about A, B, C and D being vertices, corners essentially of a running track in the shape of a quadrilateral. Bit of a weird quadrilateral, but it is a 4-sided shape nonetheless. Runners complete one lap by running along all 4 sides of the track. The lengths of the sides are measured in metres. A particular runner takes exactly 5 minutes to complete 2 laps. What we need to do is to calculate the average speed of this runner, giving the answer in kilometres per hour. So, to find the speed, what we'll need is a distance travelled. If this is a running track, we need to work out the lengths of these sides. To do that, we can work out the magnitudes of the vectors AB, AD, BC, and the magnitude CD, and add them all together. So let's do this step by step, working out the magnitudes of these 4 vectors, which will then tell us the lengths of each of the 4 sides of this quadrilateral. So to go from A to B, basically I'm going to go minus 12 back and 16 up. You can do it in this multi-step way if you want to, but you should find that from A to B is minus 12a plus 16j. In a similar way, to go from C to D, C is 50i, I'm going to D, which is 22, so I'm going back 28 i's. I'll show you that in a second. What I need to do for AB to find the magnitude is I take the coefficients, square, add, and square root. So the magnitude of A to B is 20. To work out the next side from C to D, like I was saying, that's going to be going from 50 along to just 22 along. So I'm going back 28, so minus 22i. Then from C to D I'm going down. I used to be at 136, now I'm at 24. So it's gone down by 112. Or you can use this method here as shown in part A. Regardless, the same idea as before, we now need to work out the magnitude of a vector CD to find the applied distance of this side of the track. So I'm going to do the square root of minus 28 squared plus the square of minus 112 all squared. Try that on the calculator. It will give an exact answer of 28 root 17. Now, luckily, we did AD and BC from part A, so we don't need to work out everything again. So going back to part A, we have that AD is 10i plus 24j. So if I do square root of 10 squared plus 24 squared, AD is 26. And as well in part A, we showed that BC is 5 times bigger than AD. So if AD is 26, BC will be 5 times 26, which will be 130. So the total length of this running track will be 20 plus 28 root 17 plus 26 plus 130. All these four sides added together. However, it's not just one lap this person's doing, they're doing 2 laps. It says here they take 5 minutes to complete 2 laps. We want the speed of this runner, and we want our answer in kilometers per hour. Kilometers per hour just literally means how many kilometers would this person do in exactly 1 hour. The examiner I think has been quite nice today. 5 minutes, 5 is a factor of 60, so I can quite easily scale this up to an hour. If this runner does 2 laps in 5 minutes, how many laps would they do in 60 minutes? Presuming this average speed is maintained, of course. I could multiply this by 12. 60 minutes is 12 times longer than 5 minutes, so theoretically the runner would be able to travel 12 times further. In other words, if I multiply this by 12, the same rate of speed would be that this runner could theoretically do 24 laps in a full hour. So if I add these figures together, this will tell me the length of 1 lap. But in 1 hour, the distance travelled would be 24 laps. So 24 laps will be 24 multiplied by 20 plus 28 root 17 plus 26 plus 130. If you try that, you will see that this runner in a full hour would be able to cover 6,994 point blah 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 meters. We want our figure in kilometers. To go from meters to kilometers, we divide by 1,000. So therefore, in 1 hour, this runner would be able to cover 6.99 kilometers. So if a runner can do 6.99 kilometers in 1 hour, on average, then by definition, the average speed of that runner is 6.99 kilometers per hour. And that gives us our final answer for question 6. Question 17, we have a curve with equation x cubed plus 2xy plus 3y squared equals 47. And we need to find dy by dx. We need to differentiate it in terms of x and y. This is a mixture of different skills for differentiation. We're differentiating a polynomial and also a function of both x and y. So if I just think of this in terms of 3 different pieces, x cubed I mean to say, 2xy and 3y squared, you'll probably agree with me that the easiest one to differentiate would be x cubed. So step by step, dy by dx, x cubed will become 3x squared. Now 2xy is a product, so this is going to be a product rule question. So to differentiate a product, we think of this as basically 2x multiplied by y. We hold the first thing constant, 2x, differentiate the second thing, the y, that gives 2x dy by dx, and then we hold the y constant and differentiate the 2x. So that gives us 2y. So together, we're going to get 2y and the 2x dy by dx. So leave that alone, differentiate that one, and then differentiate that one, and then leave that one alone. This one, 3y squared, this isn't a product rule, this is just simply implicit differentiation. Imagine you were differentiating 3x squared. 3x squared would go to 6x. 3y squared, treat it in exactly the same way, then just shove a dy by dx on the end. So 3y squared goes to 6y, then a dy by dx shoved on the end. So the left-hand side differentiates to this. The right-hand side is 47, which is just a constant number. That will therefore become 0. We want to isolate dy by dx now. So I've got 2 terms with dy by dx in them. So if I factorise out dy by dx now, I'll get that dy by dx brackets 2x here plus 6y there, plus that 3y squared plus 2y equals 0. If I subtract 3x squared and 2y from both sides, I get that dy by dx multiplied by 2x plus 6y equals minus 3x squared minus 2y. Finally, I can get dy by dx by dividing everything by 2x plus 6y, so therefore dy by dx is minus 3x squared minus 2y, all divided by 2x plus 6y. Or because all the denominators is minus, you could factorise out the minus here and just put it all as minus all this fraction. So these two answers are equivalent, either or will score full credit. Next, for part B, we're told this point P, which is at minus 2 and 5, lies on the curve. We need to find the equation of the normal, not the tangent, but the normal to the curve at point P. Given your answer in this particular form, A, B and C are integers to be found. Well, if we can find the gradient of a tangent, the gradient of a normal will be the negative reciprocal of that. We can find the gradient of a tangent because part A, we've got the tangent function, the derivative. It's in terms of x and y, but here we know x and y at P, so we can work out the gradient of a tangent at P by summing in x is minus 2 and y is 5. So if we do this and substitute in these points into either one of these expressions, I'm going to go for this first one here, by the way, this is just my preference. We can work out the value of dy by dx by summing in these values. So at P, dy by dx will be minus 3 times minus 2 all squared, minus 2 times 5, all over 2 lots of x, which is 2 times minus 2, plus 6 times y, 6 times 5. That will then give you minus 22 over 26 if you did it manually. On a calculator, it just gives you the simplified fraction of minus 11 over 13. That's the gradient of the tangent, though. We want the gradient of a normal, which will be the negative reciprocal of this. So flip the fraction upside down and switch the sign. Minus becomes positive, 11 over 13 becomes 13 over 11. So the gradient of a normal at P is 13 over 11. We want to give our equation in this form. My personal preference, maybe because I teach GCSE a lot, is I always think of straight lines, even now, as y equals mx plus c. So m is obviously the gradient, c is the intercept. I know the gradient of a normal now is 13 over 11, so I can say this is the same as y equals 13 elevenths of an x plus some constant c. Do I know a point the curve goes through? Well, yes I do. Once again I can use point P. If I sub in that x is minus 2 when y is 5 into these bits, I can then work out what c is. So 5 equals 13 over 11 times minus 2 plus c. So let's just work out what c is then. So c will be 5, then I'm going to add 2 lots of 13 over 11 to both sides. That gives 81 over 11. So therefore, c is 81 over 11. So in the form y equals mx plus c, our normal has equation y equals 13 elevenths x plus 81 over 11. Not in the right form though. This one here, I don't want any fractions. So what I'm going to suggest we do now is to multiply through by 11 to get rid of any denominators. That gives us the result of 11y equals 13x plus 81. I need everything onto one side and one side equaling 0. So if I just subtract 11y now from both sides, we therefore see that the equation of this normal in the correct form is 13x minus 11y plus 81 equals 0. Question 8, harmonic trig functions. 8a, we have to express 2 cos theta plus 8 sin theta in the form r cos theta minus alpha, where r and alpha are constants to be found. R is greater than 0 and alpha is in the range in radians, because it's in terms of pi, between 0 and pi over 2. In old money, between 0 and 90 degrees. We need to find the value of r in exact form and give the value of alpha in radians to 3 decimal places. This is a compound angle, cos of theta minus alpha. So as long as you remember this is given to you in the formula book, you are actually, you have a way in. So cos of one thing plus or minus another. In the formula book, you'll find this. Cos of A plus or minus B is cos A, cos B, minus plus, these signs switch, sin A, sin B. The sign we're wanting is a minus, The minus is the bottom symbol. So I'm looking at the bottom symbol. So I don't want the top symbols because it's a minus. I'm looking at the bottom symbol. So getting rid of the top symbols gives us this. What we're going to have is just cos of A minus B is cos A cos B, and then plus sine A sine B. In our case, though, we're not talking about A and B, we're talking about theta and alpha. So if we just rewrite this with theta in place of A and alpha in place of B, we have this. 2 cos theta plus 8 sine theta. We're going to set equal to R, and then all of this here, because cos of this we can rewrite as so. So all I've done at this step is rewrote the cos using this compound angle formula. Next, what I'm going to do, I'm going to factorize out anything to do with cos theta and anything to do with sine theta, then we can compare coefficients. So rearranging it ever so slightly, this is the same as r cos alpha multiplied cos theta, then this is the same as r times sine alpha multiplied by sine theta. But if this is equal to 2 cos theta plus 8 sine theta, the only way that can be true is if the r cos alpha part is the same as 2 and r sine alpha equals 8, so that the coefficients of sines and cosines match. So what we've got now is essentially a pair of simultaneous equations. We set r sine alpha to be 8 and r cos alpha to be equal to 2. I'd put sine above cos. We're going to do these simultaneous equations in 2 different ways. The first thing we're going to do, if I just call one equation A and the other one B, I can do first of all A divided by B. If I were to do equation A, top, divided by equation B on the bottom, the r's will cancel, and I'll have sine alpha divided by cos alpha, which gives tan alpha, which will be 8 divided by 2, which is 4. So by doing one equation divided by the other, we can work out alpha. That's tan of alpha, which is equal to 4. We do arctan, or tan minus 1, you could say. Alpha to 3 decimal places is tan minus 1, or arctan of 4. Make sure you're in radians, of course. You should get 1.326. The second thing we can do with these 2 equations is to square them both and then add them. So if I do equation A squared and equation B squared, I'll get r squared sine squared alpha plus r squared cos squared alpha. On the other side, I'll get 8 squared plus 2 squared. But r squared sine squared alpha and r squared cos squared alpha means I could factorize out an r squared, then end up with sine squared plus cos squared in brackets, which is equal to 1. So actually, this just gives us r squared after we square and add. We just get r squared is 68. 8 squared is 64, plus 2 squared, which is 4. 64 plus 4, hence 68. We need r in exact form, so not to decimal places, give it as an exact surd. So therefore r will be root 68, and then therefore in exact form we're going to have this. 2 cos theta plus 8 sine theta equals r, which is root 68. By the way, on a calculator it will give you a simplified surd. Root 68 is the same as 2 root 17. So in best form, write it as 2 root 17. That's r, and we had alpha as 1.326, hence that there. So now what we're going to do is see how this links to part B. Part B doesn't seem to link much at all. You're talking about a sequence now, but actually you need to spot that part A will link to this. Always, if you have a question with multiple parts, always be thinking, do the previous parts help me for this part I'm doing now? It's an arithmetic sequence anyway. We've got here that S9 is the sum of the first 9 terms as x varies. For B part 1, we need to find the exact maximum value of S subscript 9. Well, imagine adding this sequence 1, 2, third term, fourth term. If you imagine adding it together, the first 9 terms, we'd have something that looks a bit like this. Cos plus cos plus cos plus cos, dot 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 9 times. We're going to get 9 lots of cosine x. There's no sine x's there. 1 sine plus 2 sine plus 3 sine. There's going to be 1 plus 2 plus 3 plus 4, all the way up to plus 8 lots of sine x. So it's the sum of the first 8 natural numbers to find out how many lots of sine you'd have. You could do it manually, suppose, because 9 terms isn't that many, but you should find there's 36 sine x's. Simplified, s subscript 9 is 9 cosine x plus 36 sine x. How does this link to part A? Well, the coefficient of sine is 4 times bigger than the coefficient of cosine, exactly what we had here. So my suggestion would be to factorize out this, manipulating it so that this is some multiple of part A. So S9 is 9 cosine x's plus 36 sine x's. If I factorize out, weirdly you might think, a 4.5, in the brackets I now have 2 cosine x plus 8 sine x, which is exactly the expression from part A. But part A showed this can be rewritten in a more useful format, and so 2 cosine x plus 8 sine x, I can use this version of it instead. So my next line, if I just replace 2 cosine plus 8 sine with this here, I can then easier think about what the actual maximum value of s subscript 9 would be. So it's 4.5 times 2 times root 17. So this bit here is 9 root 17 multiplied by cosine of something. So cosine varies. These numbers here, of course, do not. That's fixed at 9 root 17. S9 will be maximized when cosine is maximized. So what is the range of a function cosine? Cosine ranges from -1 at its minimum up to 1 at a maximum. So the maximum value of cosine of this is 1. Hence, the maximum value of s subscript 9 is 9 root 17 times 1. In other words, just 9 root 17. So the max value of s subscript 9 is 9 root 17. Part 2, we need to work out when that actually happens. When will the maximum happen? What's the smallest positive value of x when that will occur? Well, when is cosine at a maximum? Well, cosine of 0 is equal to 1. So the first maximum we will encounter is when this expression here, the cosine of this is 0. So if I set x minus 1.326 to be equal to 0, quite clearly it must be that x would have to be equal to 1.326. Do feel free to use your calculator though. So if I were to do cos minus 1 of 1, which it can't hurt to do really, cos minus 1 of 1 is 0. So therefore, this here, x minus 1.326, needs to equal 0. Therefore, adding 1.326 to both sides, it's going to be at a maximum value when x itself is 1.326. Question 9, parametrics. We've got a parametric equation, or two in fact, x equals t squared plus 6t minus 16, and y is 6 lots of ln t plus 3. For part A, we need to show that a Cartesian equation for C is y equals a ln x plus b, where x is bigger than minus b. In other words, so that this natural log is defined. A and b are integers to be found. Now, if we compare what we want to what we have already for y, it's very much in the same format. A constant and a constant 6, ln, a constant 3 and a constant b. Anything different here is, instead of being in terms of t, it's now all in terms of x. So the feeling here is, could I get this expression, this equation, sorry, for x, all in terms of, sorry, this t value here, could I make t the subject so that I can then input what this is in terms of x to get my target? So let's start with what x is equal to. X is t squared plus 6t minus 16. To get t as a subject, what we'd have to do is complete the square on the right hand side. So we need to complete the square on t squared plus 6t. So what we do, we put brackets. Instead of t squared, we put t. We half the coefficient, so plus 6 becomes plus 3. We square that, then minus off 3 squared, which is 9. So the next step is this, and of course the minus 16 at the end. Minus 9 minus 16, of course, is minus 25. So if I add on that 25, I can see that x add 25 must be t plus 3 all squared. Now what we need to do is square root both sides. Square root both sides, we see that t plus 3 will be the square root of x plus 25. Now I always say to students, consider positive and negative root. So why aren't I considering the plus and minus options here? It comes from this. T is defined as greater than negative 3. To isolate t in a second, of course, I'm going to subtract 3. So t will be minus 3 and something else. If t is at least minus 3, and I take 3 away from it, t must be minus 3 plus something. It can't be minus something because it's already as low as it can go if it were at negative 3. So take 3 from both sides. T must be root x plus 25 minus 3. I mean, it's fairly obvious. If you thought, could it be minus root x plus 25? It couldn't. Any value of x will break this restriction on t. So it's got to be the positive root only. So now we've got what t is in terms of x. We can put this in place of t here. So therefore, y in terms of x, y used to be 6 ln t plus 3. I say used to be, it is. I'm just going to change it now how it looks. T though, if I input what t is in terms of x, y must be 6 ln root x plus 25 minus 3. That plus 3 as well comes into play. Minus 3 plus 3 will cancel. So I've just got 6 ln of the root of x plus 25. The square root of something is the same as that thing to the power of 1/2. So if I rewrite this as 6 ln of x plus 25 to the 1/2, and then recall that using the laws of logs, the power can come to the front and multiply the coefficient, this will then become 6 times 1/2. In other words, 3 lots of this natural log. So that's our final step, and it's now in the correct form. Not that we need to say it, but A is 3 and our B is 25. For the second part, we're told now that curve C cuts a y-axis at point P. We need to work out the equation of a tangent to C at P and show it can be written in this form. Well, from part A, we had that y equals 3 lots of ln x plus 25. So if we're talking about the tangent, we need to think dy by dx. So could I differentiate this? Well, ln of x would differentiate to 1 over x. ln of x plus 25 would differentiate to 1 over x plus 25. But I have 3 lots of it here, so therefore dy by dx would be 3 lots of 1 over x plus 25, or as a single fraction, we've got this. Now it says this curve cuts the y-axis at point P. When you cut the y-axis, it means it's crossing the y-axis, and when we cross the y-axis, the value of x is equal to 0. So at point P, x is 0. So if I substitute in x being 0 into dy by dx, I can find the gradient at point P. So therefore at P, the gradient will just be 3 over 0 plus 25, which is just 3 over 25. So we've almost got an equation for the gradient of this tangent at P. When x equals 0, therefore, y will be 3 ln 25. Why? Well, I've got an expression here for what y is. If I input x being equal to 0 into this, y is 3 lots of ln of just 25. This gives us the y-axis intercept. The y-axis intercept is just the value of y when x is 0. So this is how we find the y-intercept, by subbing in x being 0 into this equation for y. So then, using the idea of y equals mx plus c, I've got the gradient of a tangent, I've got the y-axis intercept of a tangent, so putting these two bits together, y equals 3/25 x plus 3 lots of ln 25. And this is in the form y equals mx plus c, as I say. The gradient is 3/25, and the y-axis intercept is 3 ln 25. I want it in terms of natural log of 5. This isn't right. ln 25 we can think of as being ln of 5 squared. And then the squared we can drop down to this coefficient and have it multiply 3. So 3 lots of ln 25, if I rewrite it as 3 ln 5 squared, this becomes 6 ln 5. So I've got y equals 3/25 of an x plus 6 ln 5. My target here has no fractions in it. So to get rid of this denominator of 25, my first suggestion would be we might want to multiply everything by 25. That then gives us 25y equals 3x plus 150 lots of ln5. Isolating the ln5 term on its own, I can now subtract 3x from both sides, so therefore, in the right form, we've got minus 3x plus 25y equals 150 ln5 for the equation of that tangent at point P. Question 10. F of x is defined as 3kx minus 18 all over x plus 4 brackets x minus 2, where k is a positive constant. We need to express f of x in partial fractions in terms of this constant k. So we know now, or should know now, how to set things up in terms of partial fractions. We're going to take this expression here and split it into two different fractions, one with a denominator of x plus 4 and the other with a denominator of x minus 2. So the initial setup is going to be something like this. Now, we're now going to multiply both sides by x plus 4, x minus 2, so we can then compare these coefficients a and b, which I've colour-coded in red and blue. So after multiplying both sides by x plus 4, x minus 2, we get the following. 3kx minus 18 is a multiplied by x minus 2 plus b multiplied by x plus 4. We can now choose different numbers, different amounts for x, such that some of these brackets cancel, one bracket cancels rather, and the other one will remain. So first of all, we could pick to go for x being equal to 2. So if we sub x being equal to 2, the a bracket will vanish, and what we've got on this side, if x is 2, we'll get 3 times 2 times k, 6k minus 18 will equal 6 lots of b, because 2 plus 4 gives 6. Then, to get b on its own, quite easily, we just divide by 6, and that will give us that b must equal k minus 3. In a similar way, we can make this b bracket vanish by choosing x to be negative 4. So now for sub x being minus 4, 3 times minus 4 is minus 12, so I get minus 12k minus 18 equals minus 6a. To isolate a, we can divide by negative 6 on both sides, and we can see that therefore a must be 2k plus 3. We've calculated a, we've calculated b, so the final thing now is just to express it in partial fractions like the question asks. So for the final step, put in a and b in terms of k as it asks for. Therefore, we've got what f of x is in the desired form. Now for part b, it says hence, which is a clue we can use part a to help us. Hence find the exact value of k for which the integral of 1 down to minus 3 f of x dx equals 21. So, because it says hence, we're going to use this easier expression for f of x to integrate. So, we're integrating between minus 3 and 1, 2k plus 3 over x plus 4, and k minus 3 over x minus 2 dx, and that needs to equal 21. So what we need to know here is that because the k is a constant and the 3 is a constant, this is just some constant on the numerator, and the denominator is x plus 4. So we can adjust this so that the numerator becomes the derivative of the denominators. The derivative of each denominator is 1. So I'm going to rewrite this integral by putting the numerators on the outside of the integrand. So if I just rewrite it like this, the first bit is the same as 2k plus 3 multiplied by the integral of 1 over x plus 4. And this bit here is the same as k minus 3 multiplied by the integral of 1 over x minus 2. This step was optional, but I'm hoping you'll agree with me that this step makes it clearer to see that we're going to end up with natural logs after we integrate. So integrating the first bit, we're going to get 2k plus 3, then ln x plus 4. In the same way here, this will give us k minus 3 ln x minus 2, in between the limits, of course. So that's what we get. So after integrating, we've got this expression, which is still equal to 21. We now just have to carefully input the upper limit of 1 and the lower limit of negative 3. So if we do that next, we'll get 2k plus 3. This becomes ln 5 minus ln 1. Over here, we get k minus 3. And when x is 1, ln of 1 minus 2 is ln of minus 1, modded. And then we minus off when we put the lower limit of minus 3 in. That's minus ln of minus 5 equals 21. Now ln of 1 and therefore ln of mod 1 are equal to 0. So we can set these terms equal to 0 and simplify slightly further to this step. So this gives us 2k plus 3, that'll just become just ln5. And over here, we're going to get minus k minus 3, and that's going to become ln minus 5. The thing is, if you multiply these together, k minus 3 multiplied by negative ln is the same as that just all made minus, because this is a minus term here. And ln of mod minus 5 becomes ln of just 5, because the modulus of minus 5 is, of course, 5. So then if we were to expand this out, how many k terms would we have? Well, we have 2k ln 5 minus k ln 5. So we're going to get just one lot of k ln 5. And in terms of the ln 5s, these 3's, I'm going to get 3 ln 5 minus 3 ln 5, which will be 6 ln 5. So this is the next step. K ln 5 plus 6 ln 5 equals 21. Subtracting 6 ln 5 from both sides gives me that k ln 5 is going to be 21 minus 6 ln 5. Final step, divide both sides by ln of 5, which gives us that k, therefore, must be 21 over ln 5 minus 6. You could have also wrote it as 21 minus 6 ln 5, all of that over ln of 5. Question 11, we've got a tank in the shape of a cuboid being filled with water. The base of the tank measures 20 meters by 10 meters, and the height of the tank is 5 meters, as shown in this figure here. At time t minutes after water started flowing into the tank, the height of the water was h meters, and the volume of the water in the tank was capital V cubic meters. So in a model of this particular situation, the sides of the tank have negligible thickness, and the rate of change of V is inversely proportional to the square root of h. Part A, we need to show that dh by dt is lambda over root h, where lambda is some constant we need to find. So how to start this off? So what I'd suggest here is to just note that the rate of change is not proportional to the square root, but inversely proportional to the square root of h. So this takes us back to GCSE, inverse proportion. So we can use that little proportionality symbol, which even teachers in secret call the fish symbol. So if V is inversely proportional to the square root of h, we can say V, the rate of change of V, dV by dt, is inversely proportional to 1 over root h. Fish, sadly, can't really do maths, so we need to replace the fish with an equals. So the next step is to say that if this holds true, then it logically follows that dV over dt will equal k multiplied by 1 over h. In other words, dV by dt will equal k over root h. That's the same as me saying k times 1 over root h. So now we need to think about what the volume of this actually would be. The volume of water is a cuboid, and as we can see here, the volume of water at any given time is going to be the length of the tank times the width times height of the water. So the volume is 20 times 10 times h. In other words, V is 200 h. So V, make a note that V is 200 h. We can now think about differentiating V with respect to t. So dV by dt means taking d by dt of 200 h. And that must still be equal to k over root h. So the 200 is a constant, so I can take that to the outside. So essentially I'm doing 200 multiplied by d over dt of h, which is just the same as dh over dt. So by reordering this slightly, taking the constant 200 to the outside, we get 200 lots of dh over dt equals k over root h. I've called this k the constant because lambda, we're not there yet, because we've got 200 lots of dh over dt. That's why I chose a different letter, if you're wondering. Now though, I can isolate dh by dt by dividing both sides of this by 200, and if we do that, what we'll see is dh over dt is going to be k divided by 200 all over root h. So what that's going to be is if I'm taking k, which is a constant, and dividing it by another number which is a constant, I'm just going to get a new constant. So I'm going to call now k divided by 200, because this is my final step, that can be lambda. So therefore, dh by dt is lambda all over root h, where I've just made a note here, so the examiner knows what I've done. I've just called lambda a new constant, which was my initial choosing k, divided by 200, after I've adjusted my answer to the required form. Now for part B. In part B, we're now told that initially the height of water in the tank was 1.44 meters, and we're told that exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24 meters. Now we need to use that information to link H with T, giving the answer in this particular form here, where A and B are constants to be found. So remembering what we had from part A, we had dH over dt as some constant lambda all over root h. What we can do is separate these variables out to get all h stuff on one side, everything to do with t on the other. So to get the root h with the dh, I can multiply both sides by root h, and also to get the dt on its own on the other side, I can also multiply by dt. So in one go, I can multiply everything by root h dt. If I do that, I'll then end up with the following. It becomes root h dh equals lambda dt. It's almost like we're missing a friend here, missing two friends. What we need are integral signs, so we can now integrate the left and the right separately, the left with respect to h and the right with respect to t. By putting these in, it just looks so much nicer. So now let's integrate both sides. Square root of h is the same as h to the power of 1/2. If I integrate h to the power 1/2, the new power will become 3 over 2. I then divide by 3 over 2, which is the same as multiplying by 2/3. So this side, I'm going to get 2/3 h to the 3 over 2. And on the other side, I'm just going to get lambda multiplied by t, plus, of course, the constant of integration. So I've got a lambda I don't know, and also the general constant of integration. But here I've got two initial conditions which will help me to work out both lambda and capital C. So first off, we're told initially the height of the water in the tank was 1.44 meters. This is saying when the time is 0, because of the word initially, when the time is 0, h is 1.44. We can substitute that into this equation to generate some more information. So we then get 2/3 of what is now 1.44 to the power 3 over 2 is lambda times nothing plus c. So that just vanishes, therefore c is whatever this is. So on a calculator, if you try 2/3 times 1.44 to the power 3 over 2, what you should find is it's 144 over 125. So in exact form, c is 144 over 125. To work out lambda, because there's two unknowns, we need an extra piece of information, which we have here. It says exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24. That means we can now substitute in when t is 8, h is 3.24. So if we do that here, 2/3 of 3.24 to the power 3 over 2 equals lambda times 8 plus c, but now we know that c is 144 over 125. This looks awkward, but we can rearrange it simply enough using the calculator. I'm going to give myself some more space and do the working over here. So what I'd suggest we do now would be to just rewrite it as simplified. This term here, if you try it on the calculator, becomes 486 over 125. Lambda times 8, I've just wrote it as 8 lambda, not touched, for 144 over 125. So if I subtract 144 over 125 from both sides, I get that 8 lambda is 324 over 125. Therefore, lambda I can get by dividing both sides by 8. So lambda must be 171 all over 500. So I've worked out lambda, I know what the constant of integration is, and so now I know that 2/3 h to the power 3 over 2 equals 171 over 500 times t plus 144 over 125. So that's what I've got here. 2/3 h to the power 3 over 2 is a subject. And you could almost be forgiven for thinking you've got the final answer here because you've done so much work. However, read the question carefully. It needs to be in the form h to the power 3 over 2 with no constant at the front. So because we've got this clear instruction here, but we need it in this form, what I need to do here would be to multiply by 3 over 2 on both sides, or divide by 2/3, whichever way you want to think about it. So finishing off, multiplying by 3/2 on both sides to get rid of that 2/3, I get that h to the 3/2 equals 513 over 1,000, lots of t, plus 216 over 125. Or if you're more of a decimal person, we can write it like this: h to the power of 3/2 equals 0.513t plus 1.728. Question 11 part C says hence, in other words that's a massive clue to use for previous parts of this question, find the time taken from when the water started flowing into the tank for the tank to be completely filled. Well, if the tank is full, just think about what h would have to be. That's the same as saying h is going to be 5 when the tank is full. This is the model from part B we arrived at in decimal form. So like I'm saying, if the tank's completely full, that's the same thing as implying h is going to be 5. So if we plug in the value of 5 for h, we can transform this equation into 5 lots, so 5 to the power of 3/2 equals 0.513t plus 1.728. We can now solve this to find the value of t, and that's the question complete. So rearrange this equation, make the t the subject, and solve. If I take 1.728 from both sides, 5 to the power 3/2 minus 1.728, that'll be what 0.513t is. Then the final step, if I divide that on both sides by 0.513, then t is going to be 5 to the power 3/2 minus 1.728, all divided by 0.513. And if we type that in carefully on the calculator, you should find you get 18.4 minutes. So about 18.5 minutes for that to be completely filled with water. Question 12 is about the number of subscribers to 2 different music streaming companies, which is being monitored using this graph. So we've got company A, and the number of subscribers to company A is n subscript A in thousands, modeled by this equation. Company B, the number of subscribers in thousands for n company B, n subscript B, is given by this equation here. T is time in years. So this is a sketch of it over a 5-year period, and we need to use the equations of the models to answer A, B, C, and D. So we need to use these equations explicitly, not go off on a tangent and use any other piece of information we may think is relevant. We're told what is relevant, we need to stick to these 2 equations. For part A, we need to find the initial difference between the number of subscribers to company A and the number of subscribers to company B. So the initial difference just implies when time is equal to 0. So when the time is equal to 0, we can just work out what the number of subscribers is going to be. So company A, if I just think of this in red, this is the top equation, the number of subscribers company B in blue. So if we just evaluate when time is 0 for both company A and company B, for company A, if I input t being equal to 0 into this, I will get that the number of subscribers is mod of 0 minus 3 plus 4. The mod of 0 minus 3, though, is just 3, so that becomes 3 plus 4, which is 7. But bear in mind, we're talking about thousands of people. So at time 0, at the start, company A had 7,000 subscribers. Company B, if I plug in t being equal to 0, I get 8 minus the modulus of 2 times 0 minus 6. 2 times 0, of course, is just 0. So it's 8 minus the size of a number minus 6. The size of a number minus 6, of course, is 6. So it's the same as 8 minus 6, which just gives 2. But again, we're talking in terms of thousands. So therefore, the initial difference between the numbers of subscribers is going to be 7,000 minus 2,000, which will just be 5,000 as our difference. And that's all we need for part A. Part B, we have to suggest a value for t, giving a reason for our answer. And what we're told here is when t equals big T, company A reduced its subscription prices and the number of subscribers increased. So if we have a look at this graph for company A, the number of subscribers increases at this point here. So what I need to do is consider what value of t is at this vertex. So first of all, just highlighting capital T, it's going to happen, as I say, at this vertex, which I'm going to put on a red dot over to highlight. So big T is going to be, if I just look down, it's going to be here. I'm trying to find what this value is. So if we look at the equation for company A's subscribers, I think it's fairly clear to see the critical value of t is when t is at 3 itself. If t is less than 3, what's inside the modulus will be negative, so we have to times this by -1. So you get 3 minus t, hence a gradient of -1 before 3. 3 or onwards, t minus 3 is non-negative, so that has a gradient of just 1 because you have 1t. So clearly, the critical point is when t is exactly 3. So to get the wording correct and to make sure you score marks, I'd suggest to put something simple, state capital T equals 3, and then just say simply because when t is 3 and onwards, the numbers of subscribers for company A is increasing. For part C of the same question, we need to find the range of values of t for when the number of subscribers for company A is greater than the number of subscribers for company B. So just labeling what we had from before, this capital T is when big T is 3 seconds. So what region or regions are we thinking where the number of subscribers for A is larger than for B? Well, the wrong region is here. We're looking for when the line for NA is higher than the line for NB. So one region is here. So if we're wanting strictly that the number of subscribers for A is greater than B, I'm not wanting this point, I'm excluding this. I want it strictly greater than, so it's everything up to including when the time is equal to 0. The other region, when n subscript A exceeds n subscript B, is from this point here onwards indefinitely, because the function is unbounded for higher values of t. So it's all of these values from here non-inclusive, all going up and beyond. So the first critical point I need to find is this one. The second critical point will be this one here, because from this point onwards, the number of subscribers from A is clearly bigger than B. So our second critical point is to find this value of t here. So as we can see, there's two clear, separate, non-overlapping regions either side of this critical value 3. So I'm wanting when the green is higher than n subscript B. Just to make it clearer, I'll highlight n subscript B in red. So essentially I'm just wanting when this red line, which I'm going to highlight now, is below the green. And as you can see, it comes in two different parts. So what I'm going to do here, I'm going to call it part A for this part. And part A, quite clearly, looking at the graph, this is when t is less than 3. Region B, if I call it, rather unimaginatively, this, of course, is when t is greater than 3 at this point. So we can solve for these two critical points separately, then combine to give our answer in set notation as required. So part A and part B. So when t is less than 3, what does this equation become? When t is less than 3, inside the modulus will be negative. So when we take the modulus of something negative, we multiply it by -1. So when t is less than 3, this will become 3 minus t plus 4. And in the same way here, because t being equal to 3 is also a critical point for this one, when t is less than 3 for n subscript b, what in the modulus is also going to be negative, so again, that sign will switch too. So the equation when t is less than 3 is actually this we're trying to solve. T minus 3 modded becomes 3 minus t, because what's being modded is negative, so we times by -1 plus 4. That needs to be greater than 8 minus, and again, we times all this by -1, because if we didn't, that would have been a negative, which isn't allowed when we take the modulus. So 2t minus 6 becomes 6 minus 2t, but we're minusing all of that as well. So it's extra tricky. We need to take extra care. So as long as we take care, we can just solve this as any other inequality. So if I add t to both sides, the left-hand side will just become 3 plus 4, which is 7. And on the other side, 8 take away 6 is 2, minus 2t was positive 2t, and I'm adding a t, which gives 3t. If we now take away 2, we can see that 5 has to be greater than 3t. Then dividing by 3, we see that t has to be less than 5/3. So that's the first part of our solution. The second part for region B is actually easier to solve. When t is greater than 3, which it will be for this section, the mod of t minus 3 is just t minus 3 itself. And in the same way, the mod of 2t minus 6 is just 2t minus 6 itself. So the equation to solve for b, just add on this is 5 over 3 as well, so we can use this later. The equation for b we're trying to solve is this one. So again, we're trying to solve it by isolating the t. So if I add on 2t now to both sides, the left-hand side will become 3t, and minus 3 plus 4 becomes plus 1. On the right, 8 minus minus 6 is 14, and the 2t, which was being subtracted, are now added, so that's disappeared. Next step, I can take one from both sides, so 3t needs to be bigger than 13. Finally, dividing both sides by 3, we can hopefully see clearly that t has to be greater than 13 over 3. I'll label this on here as well. And now, we're almost done, but this pesky question is asking us to write our answer in set notation. These two regions don't overlap, so it's not going to be about an intersection, it's going to be the union. We want this region or this one, which implies we need the union symbol, which looks a little bit like U. So the first region is this one here. In set notation, we're wanting t such that t is less than 5/3. Now, to be perfectly honest with you, what you could have said here as well, you could have said t such that 0 greater than or equal than t, then this symbol here, 5 over 3. So I guess what I'm trying to say here, you could have done it like this. T such that t is at least 0, because it could be 0, but less than 5 over 3. You don't need to put this because it's implied that you know full well the time can't be negative. So you can be a bit minimalist, that's absolutely fine. The second part of this, of course, is when t is greater than 13 over 3. So those are the two parts. We now join them with the union symbol, and that's question 12 complete. Whoops, or at least it would be complete if I had the brain cells to remember that there is in fact a part D. But never mind, part D is actually very nice and relatively painless. Part D, we need to set a limitation of a model used for company B. So if we just look at what would happen at company B, number of subscribers has got this model here. It's only defined for time being greater than 0. It's got no upper limit to it. But of course, if you can see here, if this were to carry on indefinitely along the same trajectory, number of subscribers would eventually go towards a negative, which would be impossible. You could have 0 subscribers if a company folds or is non-existent, but a negative number of subscribers is an absolute nonsense. So therefore, that's a limitation of a model. At the very least, it would need to be refined before it gets to this point. So to put it simply, a limitation of a model is eventually the number of subscribers would become negative, which of course would just be an absolute nonsense. Question 13, getting towards the end of the paper now. This first part of it is about the binomial expansion for 13 part A. We have to find the first 3 terms in ascending powers of x of a binomial expansion 3 plus x to the power minus 2, writing each term in the simplest form. Now, what we need to remember is that this one can be found in the formula book. The general binomial expansion for year 13 is as follows. So it's just a bit of a mess, but it's just like turning the gears of a crank. If you just keep turning the wheel, you will generate the marks. It's just going through the motions, it's a slog, but actually it's not that challenging mentally if you're doing enough practice with them. So, if you notice here, the first term needs to be a 1. Here, our first term is a 3, so we need to deal with that first. So factorise out the 3 as our first step. So 3 plus x to the power minus 2 is the same as 3, then brackets 1 plus 1/3 of an x to the power minus 2. We can now distribute this power to both the 3 and the bracket. So in other words, all of this to the power minus 2 is the same as 3 to the power minus 2 multiplied by 1 plus 3x to the power minus 2. 3 to the minus 2 is the same as 1 over 3 squared, so that's just 1/9. So it's going to be 1/9 of the binomial expansion of this up to the first 3 terms. So now we're going to truncate it to the first 3 terms. So if we take the binomial expansion to the first 3 terms, this will be approximately equal to 1/9 multiplied by this. So the first term is 1, hence there. Then n multiplied by x, where n is the power, x is the second term of the bracket. Hence we get the power minus 2 multiplied by 1/3 x. Then we do the power times the power minus 1 all over 1 times 2 multiplied by the second term in the brackets, all squared. If we now just neaten this up slightly on the next line, that's going to be 1/9, 1 minus 2/3 of an x, and this neatens up to be 1/3 of x squared, because this here becomes 6 divided by 2, which is 3, and then here 1/3 squared is 1/9, so 3 times that 1/9 goes back to 1/3. But because we want a 1/9 of all of this, I can then just expand out by multiplying all of these by 1/9, and we get that 3 plus x to the minus 2 is about 1/9 minus 2/27 of an x plus 1/27 of an x squared. Part B. To be honest, I quite like this question. I think it's quite clever. I dip my hat to Edexcel. Using the answer to Part A and using algebraic integration, estimate the value of 0.4 from 0.2, 6x over 3x squared, 3 plus x squared, sorry, dx, giving your answer to 4 significant figures. So essentially, this is a different numerical method for approximating an otherwise tricky integral. So essentially, we need to spot that the 3 plus x squared at the bottom is the same as 3 plus x to the power minus 2. So we can use part A like the question's saying, but it's not immediately obvious. So 6x over 3 plus x squared, that's the same as saying 6x multiplied by 3 plus x to the minus 2. So I can rewrite this as 6x multiplied by my answer to part A. Because 3 plus x squared, 1 over that, is the same as this here. So I can write it like this. And as I say, this is the case because 6x all over 3 plus x squared is the same as 6x multiplied by 3 plus x to the minus 2. Hence, we can write it as a product in case you're confused, thinking, well, that was a fraction, why is it like this? So essentially, that's just to illustrate why we get that. So now what we can do is actually integrate this. But first of all, let's just neaten up ever so slightly. So if I neaten this, basically expanding the brackets, multiplying by 6x, this becomes 2/3 of an x minus 2/27 times 6x. That goes to, times the x of course, goes to minus 12 over 27x squared, simplifies as a fraction to this, plus 2/9 x cubed dx. This isn't too hard to integrate. All we need to do is add 1 to the powers and divide by those new powers. So 2/3 of an x integrates to 1/3 x squared, minus 4/9 x squared integrates to minus 4 over 27x cubed, and 2/9 x cubed goes to 1 over 18 x to the power 4, because x cubed becomes x to the power 4, and 2/9 divided by 4 is 1 over 18. And these are the two limits, higher limit 0.4, lower limit 0.2. Because this is going to be a mess, I would suggest you do this and do it again after, so just double check you've got it right, because this is an awful lot to type into your calculator. So the first step, the higher limit, if I input 0.4, it's 1/3 of 0.4 squared minus 4/27, 0.4 cubed, plus 1/18, 0.4 to the power 4. I'm then going to minus off from that all of what I get when I input the lower limit of 0.2. So I minus off all of this, taking great care of the calculator, and I'd suggest to do it again. You should arrive at an answer of 0.033037, and so on, and so on. However, we need to give our answer to 4 significant figures. We start counting after the zeros, so we only start counting from that 3. So it's going to be 3304. So remember, don't lose a mark cheaply. Round to 4 significant figures like the question is asking you to, and the final answer is this integral is approximately 0.03304. Question 14, we have to show that the equation 2 tan theta, brackets 8 cos theta plus 23 sine squared theta equals 8 sine 2 theta multiplied by 1 plus tan squared theta can be written in this form: sine 2 theta, a cos squared theta plus b cos theta plus c equals 0. where A, B, and C are constants to be found. So this is an identity type of question, and I always consider what we're aiming for as our target. So consider what we've got and what we need to change in terms of what we've got to make it equal what our target is. So what I mean by that is, just starting off here, we can quite clearly see we've got a tan squared. We don't want anything to do with tan squared in our final step, so we need to get rid of a tan squared somehow. As well as that, we've got here a sine squared. We don't end up with any sine squareds finally, so we need to change out that sine squared too. So these are at least two things, potentially three of that tan theta we need to change. 1 plus tan squared theta, this one's a massive clue. As long as you remember the identity, it's not going to be told to you, but 1 plus tan squared equals sec squared. So that is my first suggestion. Replace this with sec squared theta. The next thing we can think about is multiplying by cos squared theta, because sec squared is 1 over cos squared. Then if we multiply by cos squared, that will give us a cos squared over here, so we're getting closer to our overall end target. So multiplying both sides by cos squared, remembering that tan is defined as sine divided by cos, so I'm going to have sine divided by cos multiplied by cos squared. 2 tan theta will become 2 sine theta cos theta. The brackets we can leave the same. Then we get 8 sine 2 theta, because the sec squared multiplied by cos squared cancels. So now we can think about changing some other things as well. So 2 sine theta cos theta, that needs to stand out to you. That's using the double angle formula. This can be replaced with sine 2 theta, because sine 2 theta is 2 sine theta cos theta, and in the same way, sine squared can be replaced with terms of cos squared. I can replace this in terms of 1 minus cos squared, and replace this with sine 2 theta. That gives the next line. I can then expand out if I want to. So, if I expand out the 23 1 minus cos squared, I get this in the inner brackets. The target, I need one side equal to 0, one side here doesn't equal 0. Now this step, you've got one of two choices. You could either subtract all of the left-hand side away, or you could just subtract 8 sine 2 theta from both sides. I'm going for subtracting the left-hand side from the right, because I want the sine 2 theta here to be positive. So what I'm going to do here, subtracting all of this from both sides, will give me 8 sine 2 theta minus sine 2 theta, and all of that bracket will equal 0. For the next step, I can rearrange. I can factorise out the sine 2 theta. So sine 2 theta, I've got 8 lots of it here, minus 8 cos theta lots of it here, minus 23 lots because I've got minus sine 2 theta times 23, and minus sine 2 theta times minus 23 cos squared theta means I need to have a factor of 23 cos squared inside the bracket, and all that is equal to 0. So now we're almost done. All I need to do now is to simplify the 8 and minus 23 to work out what this constant c is. So the final step is I see it's therefore sine 2 theta, 23 cos squared theta, minus 8 cos theta, minus 15 equals 0. So in my case, A is 23, B is minus 8, and C is negative 15. At this step, if you had gone the other way and subtracted 8 sine 2 theta from both sides, another valid final answer could have been sine 2 theta minus 23 cos squared theta plus 8 cos theta plus 15. If you got that result, that's also valid. Essentially, it's all of this multiplied by negative 1, which is still equals 0. So an alternate answer is to leave sine 2 theta positive and multiply the inner bracket by minus 1 and multiply the 0 by minus 1, which of course is 0. So that's part A done. Part B, it says hence, so we're going to use this result here, solving for the interval from 360 up to 540 for x, this equation here. I'm trying to work out when 2 tan x, 8 cos x plus 23 sine squared x equals 8 sine 2x, 1 plus tan squared x, where x is any real number, x not being equal to 450 degrees. If you can compare this here with the initial equation in part A, it's exactly the same thing, just that theta has been replaced with an x. So all we're doing here is we're going to be solving for when one side equals the other. So again, using part A, we know this can be arranged into this format here, which is easier to work with. So we can take what we've got here in terms of x and rearrange it into this form, again, in terms of x. So sine 2x, 23 cos squared x minus 8 cos x minus 15 equals 0. So I'm going to solve when this is going to be equal to 0. So we could have that sine 2x is equal to 0, or that all of this in the bracket is equal to 0. So the first option, if sine 2x equals 0, well, when is sine equal to 0? Sine is equal to 0, essentially, for all multiples of 180 degrees. So 2x could be 0, 2x could be 180, 2x could be 360, and so on, and so on. Dividing by 2 means that x could be 0, or 90, or 180. So 2x, we need multiples of 180, so we want x to be going up in multiples of 90. So which ones, if any, of these fall in the interval which works for us? So we've got 360 degrees, 450 degrees works, and 540. So it's these three here we're wanting. However, because we don't want 450 degrees, we have to reject this one. Therefore, from sine 2x equaling 0, 360 degrees or 540 degrees are the solutions from this one. We also need to consider, though, what if 23 cos squared x minus 8 cos x minus 15 were equal to 0? That will also give a solution too. This is a quadratic in terms of cos x. So if I use a quadratic formula, I can solve and work out what cosine of x needs to be. Cosine of x is equal to 1, or cosine of x equals minus 15 over 23. So when is cosine equal to 1? Well, cosine of 0 equals 1, and in fact, multiples of 360. So the solution for cosine of x equaling 1 will be that x equals 360. That's a valid solution too. Essentially, it's no real help to us because we had it from here as well, so it's a duplicated solution. But when cos x equals minus 15 over 23, the principal value on the calculator, that will come out to give you that x would be, to one decimal place at least, 130.7 degrees. That, of course, isn't in the required interval. So what we could do here is use a cast diagram if we wanted to, or we can just add on 360 degrees. If we add on 360 degrees to this to get it into the right interval size, we get that x equals 490.7. If you want to use a cast diagram, you could. So what you'd have in a cast diagram would be this here. But essentially, we've got our solutions now. So 360, we've got that twice, 540, and 490.7. This is how you could use a cast diagram for this one here. So 130 degrees isn't in the range, so we go around another 360. That's 490.7. If I went to this line here, that'd be 540 degrees, so I can't go to the T quadrant, that's going to be out of range. So putting these solutions together to make our final answer as clear and obvious and as good, therefore, to the examiner as we can, we're going to write that therefore x is 360 degrees, 490.7 degrees, or 540 degrees. That's our full solution for question 14. Question 15. A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sin x minus cos x is at least 1. So the student started off a proof. They're assuming that sin x minus cos x is less than 1 when x is an obtuse angle. So they've started it off, and what we're trying to do here is to square both sides. So sin x minus cos squared x is going to be less than 1. And that seems reasonable to me. So sin x minus cos x, if you've got a number or value which is less than 1, if you square anything that's less than 1 to begin with, it's going to be even smaller as well. For example, 0.9. If you square 0.9, you get 0.81, which is even smaller. So we've not made a mistake yet. What they've wrote is okay so far. The question we've got to do is to actually complete this proof ourselves. So we've got it written out here. So assume that sin x minus cos x is actually less than 1 if x is obtuse. So what I'd suggest we want to do here first is to just expand out this bracket. So we get sine squared x minus 2 lots of sine x cos x plus cos squared of x is less than 1. However, sine squared plus cos squared is of course 1. So these two parts make 1. So this simplifies to just 1 minus 2 sine x cos x is less than 1. I can subtract 1 from both sides, essentially cancelling the 1. So then I have that minus 2 sine x cosine x needs to be less than 0. Flipping it round, so the 2 sine x cosine x is positive, that's the same as saying I need 2 sine x cosine x to be greater than 0. At this point you might be tempted to divide by 2, but actually 2 sine x cosine x, I can use a double angle formula and spot that's the same as sine of 2x. So I'm wanting sine of 2x to be greater than 0. So we're almost actually done now. So if sine 2x is greater than 0, then essentially we know that if x is obtuse, because it says it's obtuse, then 2x is going to be reflex. An obtuse angle, of course, is between 90 and 180. Reflex is between 180 and 360. So 2x is in between 180 and 360. If I take the sine function, if I try sine, remember the cast diagram, sine of 180 degrees is 0, and sine of 360 degrees is 0 as well. So either if you picture the graph of the sine function or a cast diagram, in between 180 degrees and 360, the graph of sine is negative. So then we can just say sine 2x needs to be less than 0, because if 2x is in between 180 and 360, sine 2x is always going to be negative. This here doesn't need to be proven. You're essentially just using the established properties of the sine function. So you don't need to go any further than that. So you're just saying 2x is reflex, therefore sine of a reflex angle is less than 0, then you've got your contradiction. So then we're essentially done. Just conclude by returning to our initial statement. Therefore, if x is obtuse, sine x minus cosine x must be at least 1, because we tried to prove that it's less than 1 and we ran into a contradiction, a nonsense, which means that our initial assumption must be incorrect. Question 15 is now done. That's the last question on the paper. Therefore, we've completed the paper. So breathe a sigh of relief, give yourself a pat on the back if you've got long enough arms, and that's the job done. It only leaves me to say, sincerely, a thank you to you for watching the video, even if it's just a few questions or a few minutes. I hope you found it useful. If not, please be honest, nicely honest, and tell me how I could improve it. I'm always open to suggestions, and if you're still stuck, you know where to find me. Keep going, never ever give up, and do believe in yourselves. I hope to see you all soon. From Mr. Bailey, it's goodbye from me.